Good afternoon, everyone. Welcome back to our as usual classes, right? So, my dear students, in the previous classes we had discussed up to the topic, I think the reactivity series, right? And I'm very much hopeful that you have learned that reactivity series in the decreasing order of their reactivity, right? So today let's start a new topic, that is how do metals and non-metals react, right? So so far we have concerned regarding the metals and non-metals, right? As we have been discussing the chapters whose title is metals and non-metals. And now you know that metals are what? Those elements which can release electron or which can give electrons, right? And non-metals are those elements which accepts electron, right? Or which have the tendency to gain electron, right? Now you know that why any elements will accept or why any elements will release electron. This accepting and gaining nature is just due to the maintaining the stability or fulfilling the octet. And you know that octet means what? To maintain 8 electrons in their outermost shell, right? So the tendency of an element to fulfill the octet make them to accept or to release electrons, right? So accepting and releasing nature is due to this factor only, right? Now you know that in case of any element, the number of electrons and number of protons present in an atom is what? It's same, right? That means electrically atom is neutral. Now if any element, if it releases electron, suppose if you have considered the example of sodium, right? Now suppose I have considered the example of sodium. Okay, so in case of sodium, you know that its electronic configuration will be 281. Okay, now if sodium releases 1 electron, then obviously sodium has the tendency to release 1 electron to fulfill the octet. So if sodium releases 1 electron, then sodium will form what? Na plus. So this plus charge in an atom indicates that electron is released by that particular atom, right? So if electron releases, then it forms or it acquires positive charge, right? And if electron is accepted, then it will acquire a negative charge. Now why if electron releases it forms positive charge? The fact is that you know that in case of sodium, its electronic configuration is what? 281. That means the atomic number of sodium is 11. So in this atomic number 11, you know that number of electrons present in sodium atom is 11, right? One sodium atom contains 11 number of electrons and 11 number of protons. Now when 1 electron is released by sodium, then ultimately 1 proton would be increased, right? Because we are not going to release proton here, as sodium releases 1 electron. So 1 excess proton would be there in comparison to the number of electron. That's why it used to acquire what? Positive charge, right? So if any element releases electron, if any atom releases electron, then it will form what? Positively charged ion. And if it accepts electron, then it would form what? Negatively charged ion, right? Now you see why the metal releases electron and why non-metal accepts electron. So each and every element has the tendency to acquire the electronic configuration of noble gases, because you know that noble gases are the stable form of an element, right? That means they are stable, they don't have the tendency to react. So each and every element present in the periodic table, they have a natural tendency to acquire the electronic configuration of noble gases. Now let us see some example of noble gases like helium, neon, argon. So in this case you see the atomic number is shown here. In case of helium it is 2, in case of neon 10, argon 18. Now if we see the electronic distribution, that is electronic configuration, then you will come to know that in case of helium 2, and you know that first shell contain maximum 2, it's fulfilled. In case of neon you see 2 8, both cells are filled. In case of argon you have seen 2 8 8, that means all cells are filled, that means they are stable. If we take a look at the metals, then you see sodium is a metal, right? Now in this case of sodium you see 281. So this shell, that is M shell, right? This is the M shell. M shell is not stable, or it is not fulfilled. So what sodium does for this purpose? If sodium wants to become stable, then sodium must release this one electron. If this one electron is released by sodium, then its last shell would be second one, right? That is L shell, which will be fulfilled one. In case of magnesium also you see 282. Magnesium will have the tendency to release 2 electrons so that it can acquire a stable configuration. If you take a look in case of non-metals, then you have seen here in this chart, suppose I have considered oxygen. In case of oxygen you see atomic number 8, so its electronic configuration 2 6. So in this case you see the second shell, which is named as L shell. In this L shell you have seen that 2 electrons are lagging, that means deficiency of 2 electrons, or somewhere if oxygen can manage 2 electrons, then oxygen will have a configuration in which all cells are fulfilled, right? That means a stable configuration would be reached by the oxygen. So that's why oxygen will accept what? 2 electrons. So this is the nature of metals and non-metal. That means metal has the tendency to give electron, and non-metals has the tendency, non-metals will have the tendency to accept electron, so that they can maintain a fulfilled electronic configuration, right? So for this purpose let us take an example, and very well known example, that is formation of sodium chloride. Now during the formation of sodium chloride you see what are the elements, what are the atoms involved regarding the formation of sodium chloride? It is what? Sodium and chlorine, right? Now how it is formed, you see in case of sodium its electronic configuration, if it is written, it would be what? 281, right? In case of chlorine, if it is written, then it would be what? 287. Now you see, if sodium releases 1 electron, then so far we have discussed that sodium will form Na plus, right? 1 electron is released by this sodium. So you see sodium electronic configuration 281. After releasing 1 electron, it will be what? 28. Now this chlorine, as its electronic configuration indicates us that 287, which means that it has the tendency to accept 1 electron to get a stable configuration. So chlorine will accept 1 electron to form chloride ion, right? Which has the stable configuration. So ultimately both have the tendency to give and take. That means this give and take nature is found while the formation of sodium chloride is being discussed. Now how it is done? As you know that while taking part in any reaction or for the formation of molecule, then what is the factor? The factor is that only outermost shell will take part. So the outermost shell of sodium contain how many electron? You see 1 electron. In case of chlorine also, outermost shell contain 7 electron. So you see sodium, as outermost shell contain 1 electron, this 1 electron is shown here. Chlorine 2, 4, 6, 7. Now this sodium will give 1 electron to the chlorine, right? As a result, as sodium has given 1 electron to chlorine, then we have got that if electron is released by any element, then it used to form positively charged ion. So sodium, by releasing 1 electron, it will form Na plus. Okay. In the same manner, chlorine already it has 7 electrons, right? By accepting 1 electron from sodium, chlorine will acquire 8 electron in its outermost shell. As electron is accepted by the chlorine, that's why chlorine will contain a minus charge. So this Na plus and Cl minus, this is just nothing but what the formation of sodium chloride. Now this sodium chloride, it is to be noted that it is not considered, that means it doesn't exist as molecules, but it is termed as aggregation of oppositely charged ions. That means what? This sodium chloride exists due to the fact that the strong electrostatic attraction present between the positively charged sodium ion and negatively charged chlorine ion, that means sodium and chloride. So due to this strong attraction present in between these two, cation and anion, this exists as what? An aggregation of oppositely charged ions. Okay, so today up to this it will be okay. Go through each and every topics and read it carefully. Okay, thank you.